Hello people, it's TJ and welcome to Science Simplified. Now a lot of us find it difficult remembering the position of images formed by a concave mirror. But then, worry no one, put a smile on your face because I've come up with an easy way to remember the position of image formed by a concave mirror. Okay people, let's get to it. The first step you need to take is to represent every position on your concave mirror by numbers 1 to 6 and 0. I'll show you what I mean by illustrating with a diagram. Now I'm going to show arrows pointing to the different parts of the mirror. This is what it looks like. And just below, I'm going to show what each of these points mean. You can see here that 1 represents infinity, 2 represents beyond C, 3 at C, 4 between C and F, 5 at F, and 6 after F. Not forgetting 0, which corresponds to behind the mirror. We then simply note that image plus object position equals 6. This then simply means that image position equals 6 minus the object position. Okay people, now let's try it and see if it works. For the first example, where would be the image position if object position is at focal point? For better understanding, I'll pull up the illustration from our previous slide. Now we see here that the focal point of the concave mirror is represented by 5. And then remember that our formula says image position equals to 6 minus object position. So this means image position will be equals to 6 minus 5 meaning our object position, and this equals 1. Now looking at our illustration again, 1 points to infinity. So this then means that the position of our image is going to be at infinity. You can pause the video and try the next example. What is going to be our image position if the object is placed after F? Again, I'll pull up the diagram for more understanding. After F points to 6, this means that object position is 6. And from our formula, image position equals 6 minus object position. This means 6 minus 6, which is 0. Not to forget, remember that 0 corresponds to behind the mirror. So this then means that our image position is behind the mirror. Now, to easily remember if the image formed is magnified or diminished, we could just easily note images formed at 4, 5, and 6 are diminished. But then images formed at 0, 1, and 2 are magnified. We have one special case. This would be images formed at 3. They are going to be same size as objects. So we see that the representation is somewhat opposite, in which large numbers represent smaller sizes and small numbers represent larger sizes. From this, we'll move back to our previous slide and determine if the image produced is magnified or diminished. Back in this question, we said the object was at focal point, and so then the image formed at infinity, which is 1. Remember that we said that images formed at 0, 1, and 2 are magnified. Since in this case the image is formed at 1, it then means that the image is magnified. For the next question, we said our image formed at 0, which is behind the mirror. 0 is a small number and so corresponds to a large sized image. So this will mean that the image is magnified. And finally, all images formed in front of the concave mirror are real and inverted, while all images formed behind the mirror, that is at point 0, are virtual and erect. Okay people, that will be all for now. Thank you for watching. If you loved this video, you could click the like button, and to get more tips and tricks like this, click the subscribe button. Thank you once again. Bye.